Welcome to this episode of AU Manufacturing Conversations with Brent Balinski, sponsored by SPEE3D. If you're interested in metal AM, you can download their latest white paper, Metal Additive Manufacturing, the Opportunity for Heavy Industry, in the show notes. Now on with the show. Steve Camilleri, welcome to AU Manufacturing Conversations, the only returning guest ever, so congratulations on that. Lovely to be speaking to you.
Yeah, good to be talking to you again, Brent. I really enjoyed our last interview. I do still think of it occasionally. You had some pretty inspiring questions in there, so let's see if we can do it again.
Well, may the mutual admiration continue, because I had much fun and I enjoyed it a lot. If anyone's curious about the previous one, that aired in October last year and was episode 25. So if you enjoy this conversation, go back and check out the other. Let's kick things off. I wanted to start with a broad, sort of almost philosophical question. I've heard Byron describe to an interviewer before that he sees SPEE3D as an industrial software company. Some would say you're an OEM and clearly a manufacturer. Others would say that it's really hard nowadays often to make a distinction between manufacturing and software, and I'm sort of in that camp. But more interesting than that, what are your thoughts?
Yeah, well, I think I'm pretty happy with Byron's description, but there's another description I've heard mentioned, sort of a modern term called shardware. Have you heard of that one, shardware?
That's a first.
I'm not sure who coined that one, but that one resonated with me a bit. So the idea is that it's really a software product, but it needs hardware to deploy. So, in the first days of the computer, it was very similar. Like, you'd pay IBM and they'd demolish a floor of your office building and put one of their computers in. And then at that point, they were essentially a software vendor. It's something like that, I think. It's a software technology that really needs hardware so that you can use it.
Well, that's a nice, neat sort of way of thinking of it, and why not? We won't rake too much over old territory with the previous conversations and some of the explanations that you gave, but I wanted to ask one sort of contextual question. Both you and Byron, the co-founder at the company, have pretty decent-sized careers of entrepreneurial engineering at InMotion Technologies and now at SPEE3D. Was this a sort of surprising path looking back on one that you would have imagined when you were enrolled in electrical engineering?
Yeah, to be honest, I probably wasn't really sure what I really wanted to do in specific. I've always been quite certain that engineering was the right answer for me, going back to a very, very early age. My parents used to get very depressed that I used to disassemble all the devices in their house, but they were always quite surprised that I could reassemble them successfully. So this is a very young kind of little tacker. So engineering's always been obvious to me as a thing to do. I love building tools. I love building systems. I love working with tech. But electronics, I quite enjoy. But, it's a little bit abstract maybe. And I think if I could make the choices all over again, I'd probably want to go into more system engineering, mechanical mechatronics control mixed with material. And really that's where we are with SPEE3D. So I would never have predicted this in the early stages. This would be where I'd end up. But, the moment that there was a cheap polymer 3D printer on the market, I bought it immediately, just to my wife's dismay. We were printing stuff in our home kind of 2008 or something. So pretty early days. The idea of manufacturing's always appealed to me. And the idea of tech's always appealed to me. So I guess it would make sense to be doing something like this, but there really were no opportunities at the time that would have led in this direction. So electronics was where I started. And I'm still quite passionate about it, energy in particular. The movement of energy and the efficiency, renewables, they're all still areas of interest to me.
Well, I guess the movement of energy is never going to become less relevant over time.
Yeah, indeed. So much of the really complex physical problems in the world that people think on deeply and really struggle with can be very simply explained by just understanding what the energy is doing. I had a mentor early in my career, my old professor, Dean Patterson, who was very passionate on this subject and very, very well, kind of very philosophical. Yeah, you see the world differently when you start thinking about energy, its conservation, waste. But, you can look at something like a 3D printer you've never seen before and say, well, there is or isn't enough input into that process for it to be doing what it's doing. Therefore, it is real or isn't real. It's a nice way to shortcut some things.
So let's get back to the company. What's the size of SPEE3D 8 or so years in?
So I think we're about 70 people, and we're roughly doubling year on year, which is a very high rate of growth. It's actually quite difficult to manage that rate of growth. You hear these stories about companies getting to the high growth stage, and I'll now understand why that's an ominous kind of a thing to talk about, because you really just, every day is just a process of managing fires and keeping lids on things and trying to be strategic. So it's it's a much better problem to have than does the world care about what we're doing? The problem you have slightly earlier. But yeah, we're definitely getting to the stage where the business is getting more and more complex to manage. It's not something we can run in our own heads anymore. We're desperate not to not come unstuck at this stage of growth, pushing very hard to understand it as we go.
Tell me about your strategy for raising capital and expanding so far. What's it look like? What have you sought in investors? And you possibly can't talk about who they are at the moment. I know you haven't discussed that publicly before, and that's fine. But how have you gone about attracting capital, and what do you plan to do in the future?
It's a very interesting question, this one. So people get asked about how they raise capital and where they raise capital, but very rarely why they raise capital. So I think this is a very interesting question. I think in the early stages of a business, it's really important to manage your costs as best you can and work off things like grants. So the Australian government is very, very good at supporting small business, partially supporting small business, co-investing in small business and growing up, especially new technology, speculative stuff. So, they were very supportive of us, our state governments and our federal government in the early days. Byron and I had come out of a successful business. We were able to fund that ourselves as well. So when you start getting to the stage where you need kind of big C capital, where you start needing infrastructure, and there are big price tags on items, and you've got to start trying to understand where those are. And, you're thinking about new products, you've seen new opportunities, like how do you fund that kind of thing? Traditionally, at least in the US and Europe, you'd be looking at venture capital for a lot of that stuff, growth funds. We're still not very good at this in Australia, to be perfectly honest. This is an open secret, right? Most people will know this. We've got about the same population as Florida, somewhere between Florida and Texas. And we like to think of ourselves as a big nation because we're kind of US-sized or, Europe-sized. But in reality, there's a relatively small pool of people here. It's like saying in the US, I'm going to grow the entire company up and fund it and work just out of Florida. I'm not going to go outside that boundary anywhere. It's something that you'd be considered crazy to do in the US. That every Australian company finds themselves in that position. So growth funds is the short answer to your question. Why do you look for capital investment? It's to grow. Growing organically is often seen as the low risk option. Like, let's sell stuff, make money, and then use that money to grow the company. But it's actually the highest risk strategy. So this is written in a range of different places. But if you're growing too slowly and suddenly competitors with deeper pockets turn up and try to duplicate what you're doing, you can't compete with them. It's quite risky to grow organically. So in those first early stages where you've got this fledgling infant company, it's really quite defenseless. You've got to not be that as soon as possible. So this is just, evolution. Growth capital is where you go. I'm not sure what recommendations I give to other people in our position. I would say look here by all means, but also look overseas in parallel. The markets in America think very highly of Australian companies. They do need to wrap their head around investing outside the US, and that's definitely an issue for them. So you need to give them some comfort that they can invest in you in Australia successfully. And we really need that competition to drive the industry here in Australia. There's got to be other places that will succeed. With Australian venture capital industry is too risk averse. That would be the advice I'd give. As a growth company, we're growing fast. We're going into new markets with new products all the time. We're constantly raising. ABR is what they say in the industry, always be raising. We're no different because what you need is opportunities to grow and become better defended as a result.
You're expanding into new markets all the time and moving machines. How many units are out there in the field and what countries are they in?
So I think we're up to roughly 50 at the moment. I couldn't tell you exactly, and there's a lot happening. The US is definitely a big market for us. The deal with Ukraine recently has been a very big deal for us. That's for 7 systems. That's all been published already. So now we've got other deals coming up with the Japanese government and the UK government. In Australia, not so many. So I'm just trying to think how many commercial systems we have in Australia. Probably in the range of 5 to 10. I'm just trying to think where they might be. Sorry, I don't really track this figure in my head so well. But, to be honest, it's an export market. And I think that makes sense given the Floridan size of our market here. The printers, like metal 3D printers, aren't cheap. It's just the nature of it. There's a lot of work to do, a lot of energy to be moved around to be a metal 3D printer. So they have a price tag, and you've got to go to the places where people can afford that capability.
And you might not be able to give exact figures, as was the case just then, and that's fine. But last time we spoke, you said that defence had emerged as a pretty important market for you guys, and I think about half of your units, if memory served, were in defence, something like that. But anyway, on the whole, it was on the up and up. Excuse me. Is that remain the case?
Does defence remain the biggest part of our market? Yeah. At the moment, I would say yes. It's a range of different stuff, though. Like a lot of people kind of assume that we're focusing solely on the expeditionary stuff, the work in the field, which is definitely a big piece for us. We're also starting to work on the proper supply chain, the formal supply chain. So in those cases where there are people building platforms that are having trouble getting parts for those platforms in a reasonable period of time, which is definitely a thing at the moment. The US government's been very vocal in the media about this. We get approached and asked about, could our technology resolve this or that supply chain issue? So we announced earlier in the year that we were working with the US Navy on some of their materials. Looking into it now, those materials are quite hard to make. They're materials that need a lot of skill in the foundry where they normally cast. The reality is Australia, US, UK, we've kind of got to this position where we don't like dirty industry. And foundries are considered a bit of a dirty industry, which, is kind of horrifying because foundries make a range of things that are quite critical to our existence. To kind of dismiss that way of making things it's a little short-sighted, I think. But nevertheless, here we are. The guys in the boiler suits with the spacesuit over the top, pouring the metal and sparks flying everywhere. Like, we just don't like the look of that, it would seem. There's still a few around in Australia, which is fantastic. And there's still a few around in the US and the UK as well. But the industry is definitely not growing. It's kind of in decline. And where there's high levels of skill required, what do you do? How do you keep those skills in that industry? So people retire. The skills retire with them, and some of these alloys that are needed, it gets very difficult to make them. So we've been asked to have a look at ways of using modern additive and advanced manufacturing technologies to make those materials, and we've been very successful with that. Of course, we can't claim that it was made the original way, but we've got to the point where, I can show the materials to a professional metallurgist and they would find it very difficult to distinguish the material made with our process versus the foundry processes, irrespective of how they tested it or cut it up and looked at it. So our process is flexible enough that it lets us do that. And that's a quite different application to the expeditionary one. So it's still kind of defense-centric, but when you think about it, the maritime industry needs parts like that. The mining industry, the oil and gas energy industry, rail needs parts like that. And the reality is that part of the consequences of moving on from some of these dirty industries is we've got to have something to replace them with. So, we think of 3D printing often as the ambulance at the bottom of the cliff. That's certainly how people seem to think about 3D printing outside of the 3D printing industry. So they come to us, right? We've tried everything. We've got beat up on our way down the cliff, and here we are. What can you do? So we're doing a lot of that work as well, which is defense work at the moment. But we'd love to transfer that out into more conventional industry.
Right. And that, I imagine, will emerge later because that's the way it is with defense-related technologies. So tell me about cold spray. I know it's a big term and it's something that you could trace back to 100 years ago in some form or another. Most people go back to the 80s and Russia. I'd like to know sort of how mature you consider it as a production technology, how many companies are working on it at the moment, and what are the unaddressed problems that are being looked at?
Okay. Cold spray is actually a relatively modern invention. So, the 1980s at a research institute in Siberia kind of came up with the original concept. It's been a bit eclectic since then and in and out of different industries. When Byron and I happened on it as a way to solve the speed and cost problems we had with thermal metal deposition, at the time, there were a lot of unresolved things around the technology, which we've been able to resolve, which is why we can now 3D print with it, make these, arbitrary shaped parts. There's really three classes of cold spray. So this has never been done so formally, but certainly in my head, this is the way it works. So there's three classes. Cold spray is a rocket engine, essentially something that shoots a gas, nitrogen or helium or air through an energy converter. So it's a rocket engine, converts heat and pressure to velocity. That velocity accelerates the metal powder, which causes it to bond on impact. So when you can get it supersonic enough, that's what happens with the powder. That's how cold spray works. There's a handheld version that's been around for a while. There are a range of vendors around the world working on that. And it's fascinating because it's a wonderful repair technology. If you've got a metal casting, so again from a foundry, it's got corrosion damage on it, corrosion being one of the more common wear out issues on a casting. And you don't want to have to recertify the casting. You don't want to kind of melt it and recast it and make it a new part and then have to do all the work proving that it's a good casting. But you just want to do some kind of tidy up on the casting so that, for example, it'll take a bearing again or it'll hold a seal again. It's been kind of chewed out a bit by corrosion. You buy a handheld cold spray system, you add material, machine it back, and really you would never know that had been repaired. So because you're not heating the casting when you're putting the material down, you don't damage its temper. So you don't really need to recertify it. So the argument goes, right, which is a good argument, I think. So that's handheld cold spray for repair. Quite actually practical. There's another one which is robot held, where the cold spray gun goes into a robot's hand. And if you want to apply an even coating onto something, you need a robot to kind of step back and forth and very precisely control how much material goes where. So the majority of cold spray systems in the world are one or the other of those. So we're really on our own in this third category, which is doing additive manufacturing with cold spray, where we can take an arbitrary shape that we've never seen before, put it into our software, automatically calculate how the robot should move the nozzle around to build that part up from zero, and then reliably build the part up from zero the first time we try. There's no competitors really in that space, which is good and bad. I mean, it'd be nice to have a bit of pressure from some other industry, but at the same time, we're off solving all the problems first, which is just a fascinating time from a technical point of view. And to be honest, where it might go, this business of depositing a material without heating the material especially much, like depositing it solid, brings a whole range of very interesting possibilities to the fore around what the material might do. And in fact, this business of kind of reproducing old material systems that we're doing now, the things the foundries can't do anymore, that's really only possible because it's cold spray. So if we were doing it with a laser, melting the material, it wouldn't be possible. So I think if I want to be very grand, I think there's probably a whole kind of metallurgical handbook of ways to make material based on cold spray type processes that are in the first instance solid state that's coming, because we've just found it so advantageous. And, we're kind of on our own. We're talking to material scientists regularly in universities and places going, yeah, look what we made. We made this thing this way. And the response is like, oh my God, I've worked my whole career on ways of solving that problem and you've just done it in an afternoon. Like, what else can you do? So we're having those kinds of conversations all the time, which is just fascinating. So hopefully we start to get more and more research institutions on board looking at what else you could do with this particular technique to build novel materials and new materials. So if we think about all the needs of, space, and I mean, defense needs it one, but, you want to make a oxygen tank on the moon. Like at some point, people are going to want to do that. And this is a fantastic way to do that. I mean, the process actually works better away from Earth. So, there's somewhere out there's a race of argon-breathing aliens that have way better metallurgy than us. Oxygen's actually a real problem. So that's a huge opportunity to look forward to, is this idea of moving 3D printing off planet and starting to work with it in different environments, because it's actually got some big advantages.
Well, I imagine your development pipeline looks pretty crazy, but you don't really discuss it so much. I guess you're probably not asked by the press very much about what you hope to be doing in 10 years or whatever, but you've got some ideas.
Well, yeah, certainly. I think what it comes down to is just making the process more and more accessible. So right now we've got a world where a lot of people think of manufacturing as something that's undesirable. They wouldn't want their kids to be doing it, but they're thinking about, giant warehouses full of smoke and steam and ash. Manufacturing is not like that anymore. I'll tell your listeners, if they've got children that are interested in advanced manufacturing, look, there are huge opportunities going at the moment in material science and design and, engineering and testing. Like, this is all the stuff that's the good stuff of manufacturing. We still need it, and it's not a dirty job, and we should be thinking about it. I think as a nation in Australia, certainly we should be thinking more about it because it suits us quite well.
Yeah, I believe that is all true. However, I would add that I think that we've done ourselves a kind of a mild disservice by emphasizing advanced manufacturing so much in, like you mentioned earlier, about sort of dirty-ish industries. I mean, they're still important industries. We still need injection molding. We still need forged and cast parts. We still need bits of metal bent into other bits of metal. And I don't think that as a nation, it's a good idea to say we can only do these high-tech things because they're underpinned by a lot of lower-tech things also.
Yeah, I totally agree with that. And in fact, there's this kind of assumption that the future has only advanced manufactured stuff in it, only 3D printed stuff. And I totally disagree with this concept. I mean, there are a range of things that you might make that are improved by being standardized. So think about a bolt. The idea of custom making a bolt, like there's just no appeal to that idea. The material's made in volume. It's an amazing material in a bolt. Bolts have some of the best materials of anything that you might ever touch. And you buy them for $1. You buy a giant bolt for $1. It's incredibly reliable. It'll happily screw into anything else. It's the same standard. The idea that you might at some point 3D print those, like it's just nonsensical. I mean, look at pharmaceuticals, like the idea that you might someday be 3D printing, paracetamol or something in your house from kind of vats of chemicals. Like, I mean, that's kind of terrifying. I would much rather have the kind of paracetamol that's made 1 million tablets an hour in a giant factory because, the quality's there. The quality's where I want it to be. I think this is just common sense will eventually prevail, but there's a lot of bad assumptions in the market at the moment around advanced manufacturing, I think.
I wanted to turn to another topic to do with what Australia can and can't do, and I wanted to look at metal powders for a moment. Every now and then you see a bit of excitability. A few years ago, we had a lot of people interested in making titanium in Australia and some good research being done on processing that. Not sure what's happened to it. It's sort of fallen off the map. But, every now and then people think we've got this high value thing in abundance. If we could just process it, it'll be sweet. We'd make so much money. And I see the appeal of that. What's your view on the potential to add value by processing metal into powders and doing the transformative work here rather than just selling ore?
Let's look at the economics because, there are figures here that we can talk about. So I'll speak generally. For example, alumina, which is refined bauxite, aluminium oxide, we sell for about $1 a kilogram, roughly speaking. So, it's a semi-processed ore. Aluminium, on the other hand, like aluminium ingot, it goes on the market for about $2 a kilogram. And in Australia, we've got to put $3 or $4 worth of electricity into that alumina to make the aluminium. So you can see there's an issue there immediately. Electricity's got to be cheaper. I mean, this is one of the reasons why bauxite mines tend to be near shorelines, is so you can move the raw products to a place where there's cheap energy, relatively low cost. We've got to crack that one, and that's not really an advanced manufacturing problem, that one, but it's quite crackable all the same. Having done so, we might be exporting aluminium for $2 a kilogram. If we were to turn that into a high quality, quality controlled feedstock for an additive or advanced manufacturing process, it's probably worth about $50 a kilo. That's a $48 a kilo delta in value, uplift in value. So it's a huge value add. So we'd need to do that properly and well. We'd need to invest in all the quality and capital required so that material was a high quality material that was readily usable. These are all relatively simple problems to solve. Now, the parts themselves, generally speaking, like quality aluminium alloy parts, run at between maybe $100 and $300 a kilogram. So if in Australia we could solve the energy problem, although by now you'll know that's not mandatory for the economics to work, and then make a powder and then make a part, the uplift per kilogram is potentially hundreds of dollars per kilogram. So, what would we prefer to be exporting, really? I mean, if we're exporting, I don't know, let's pick an example. Let's say we're exporting electric moped scooters. The world needs more of those, arguably. So lots of aluminium structural parts in that. Potentially, we're just exporting the raw product. There might be $5 of value into it, or potentially the completed product, largely completed in terms of parts or totally completed in terms of a product. And you're looking at hundreds of dollars every time you do that. So for essentially the same stuff, the same atoms configured differently. We have a crisis of confidence in Australia here, I think, around manufacturing, largely because of the automotive industry and what happened with that. People are still smarting over that issue. But the size of our labour force and our labour costs has, I think, traditionally been the issue that people have been tripped up by. Advanced manufacturing kind of solves that problem. It makes it far more about design and intelligent product orientation and kind of service and engaging with the market. And we're fantastic at that stuff. The other part of the equation is the material cost. And we have some of the cheapest material in the world. Like just about whatever you need, we can dig it up from somewhere. So we're not adding value to it because we feel like we shouldn't be manufacturing. That's my general view on the subject. We think of it that because of a reason that's essentially a little fossil. It's a little social fossil, this idea that we don't have the labour cost to do the conversion. Advanced manufacturing takes that problem off the table.
Sure. Well, there are plenty of nations with expensive wages that are doing very well, thank you very much, at advanced manufacturing. So we should think more about that. Anyway, I wanted to look at a very different subject, and that's the sort of micro trend lately of high-profile, high-tech Australian manufacturers either moving their manufacturing to the United States or in some cases moving everything to the United States. There are obvious reasons for it around subsidies, around the various sweeteners rolled out for companies to move over there, and every company goes where it's viable. All this sort of throat clearing is sort of to lead up to the question, is there a big pull for SPEE3D to go to the US, or do you think, you'd like to remain Australian indefinitely?
So I think among the founders, Byron and I, there's a strong desire to keep the company Australian. So we've gotten a huge amount of value out of the people that we work with here. So I'm not saying that we haven't overseas. We certainly have. There are good people around everywhere you look. But the attitude that Australians bring to innovation, I value. And it's an attitude of professionalism, actually we understand the problem, and an attitude of irreverence. You know what? Maybe pick, insert giant company's name here, hasn't got this right. Maybe they don't have it right, and they might have good reasons for that. But our spreadsheet says there's an opportunity here. We should be looking at this. So we're quite happy to jump into that frame, and that's not normal. You go around the world, so Australia and New Zealand, we both have that same attitude. And if you ask me, I'd call this an agricultural attitude. This is farmers with fencing wire. This is in our, social. Yeah, exactly. I find that quite valuable. I found I don't have any problem getting people from other places to kind of adopt that culture, but you've got to kind of convince them it's okay. And they love it once they work out that that's the way it works. So I think that's something very rare and precious that we have here. This is a very important feature in our way of thinking here in Australia. And we don't prize ourselves for it, is the other thing. We don't value ourselves for that. We're one of the world's biggest iron ore exporters. It's not because our labour cost is low. It's because we're very, very clever at figuring out how to get that stuff out of the ground and get it out and make money off it. So this is clever people. This isn't silly people. I'm not a big fan of this whole banana republic kind of argument. In terms of kind of where the company might go, so we're transitioning now from being an Australian company to being a global company. So that's going to mean a presence in other places. One of the key issues with Australia is the logistic time, getting stuff in and getting stuff out. Our customers value time. That's why they're looking at advanced manufacturing. It's because they want stuff faster than they could get it otherwise. That's really one of our key value propositions, is the ability to do things faster. And advanced manufacturing, it's an underrepresented value of advanced manufacturing, is solving problems quicker. So, that does factor in. So I couldn't tell you for sure, I couldn't promise that we're going to retain 100% of everything here in Australia. I mean, I can promise that we've got to grow internationally. But, I think there's this kind of little engine of innovation in Australia that's quite important to value and recognise and maintain and improve on. I'd suggest other companies should be doing the same thing.
Well, that's a refreshing answer. I mean, we all hear Australia get beaten up on about the things it can and can't do, and I sometimes do some of that for what it's worth. But the idea that we can be very effective due to the professionalism combined with irreverence in our nature, it's an appealing thought, and I liked hearing it. You mentioned some R&D problems earlier that you're looking at in the shorter and longer term. Tell me about what drives R&D at the company. How do you identify problems? How do you keep R&D meaningful rather than sort of veering off on a tangent somewhere?
There's a book on this that needs to be written. I've kind of contemplated writing it on a few occasions. There might be a future collab there maybe. But the idea is that innovation, like bringing a new technology into existence, it's important to be customer-centric, but you've got to set that lever very carefully. So Henry Ford had this famous saying, if I listen to my customers, I'll be breeding faster horses. That's definitely a factor. You've got to make sure that you're not adopting solutions customers are proposing to you. Listen to them, but what you really want to know about is their problems. So being customer-driven, customer-led, in terms of understanding what problems need to be solved. By all means, listen to the solutions as well, because there's a lot of value in that. But you really want to be honest and uncompromised when it comes to thinking about the solution. So this is what the R&D activity always has to start with, is a very honest and open and kind of criticism-free discussion about what the problem is that needs to be solved. Why are we here? Why are we trying to solve this problem? Why is it important? Lots of those why questions. And then people always like to jump into solving the problem too early. So you've got to kind of keep everyone chilled out and talk about the problem until you feel like it's understood. Just to give an example, we were very fortunate during the pandemic. We were out in the field with the Australian Army 3 times looking at solving their problems. And that context was completely invaluable to me and the team. So they're fantastic to work with. I mean, for future reference, I'd recommend working with the Australian Army to anyone, like professional, clever, just like us. We're out in the field solving problems. They're solving problems. They're the same kind of irreverent kind of farmer mentality, but with the pragmatism behind it. So we had a great time, far better than I usually like to admit to. And it really moved along our thinking about what 3D printing needed to do by being there in their context and kind of observing what the realities were. Like R&D that's done in a lab with a terminal, it only applies to some fraction of the kind of problems that you might solve. The kind of problems that we solve are the problems that involve the real world and physics and interaction and delivering outcomes that are physical and real. It's quite easy to tell when you've done that badly. Orienting your R&D team towards understanding what the problem is and then delivering the real measurable practical outcomes at the end of it, I think that's the trick. It's not really, it's obvious in hindsight, right? This is not really, there's nothing special in here, but you'd be shocked maybe how little this happens around the place. So anyway, hence the book.
I've seen some companies, some of them made up of rather brilliant people who are sort of in awe of, not do well because they were in love with technology. And I always see it as a bad thing when they think about that rather than what they could be solving with it. And that's, I guess, a way to do R&D and innovation.
Yeah. And I think 3D printing is as guilty of this as any other new industry, right? So I think a lot of people are in love with laser powder bed fusion. And I don't like to be critical of a particular technology, but this is one where it's very cool what happens. You're using high intensity light to weld material together and make a part, a beautiful looking thing. But, the underlying energy management of the system, the underlying physics is not terribly efficient, actually. It's very slow. There are people kind of in love with the way that it works and not so much the outcome of it. It's very distracting when that sort of thing happens. It wastes a lot of oxygen.
I guess if you have a application that's high value enough, if you're Bastian cycles, then that makes sense. But if you're everything that's cheaper than that, which is just about everything, then you're going to struggle to make a case for that laser machine.
Yeah, exactly. And we don't drive steam cars around anymore, right? Because it just wasn't efficient enough. Much as we like steam, steam's wonderful. But the idea of everyone having a car that uses steam to convert energy and move it around the car, we gave up on that because there were more economic ways of dealing with the problem. And 3D printing has got to go the same way. And I think it is going the same way. It's got to be economic. Being in love with the technology doesn't get you there. It's a great way to get media attention, but it's ultimately not the right answer if it's not economic. So the most economic process will win usually.
That's the way it works. We're running towards the end of this interview. One thing I wanted to ask you about is the way the two main places from which you run things are Melbourne for manufacturing and Byron's turf and Darwin, which is your patch. It's an unusual arrangement. Tell me about why you've chosen to do things that way.
So there are good practical reasons behind it. I guess that's the first part of the answer. So, I was fortunate enough when we were working in our first company, I was working in Darwin, solving problems, working on technology. And then when that company was acquired, they moved Byron and I to Melbourne. He stayed, I came back. I found that I had a much more difficult time doing my job in Melbourne. And it took me a couple of years to work it out. But just the business of being in a very large city that's very difficult to get around. I don't want to generate hate from Melbourne people here. But, I was driving 9 kilometres to work and 9 kilometres home, and it was, a 60 to 90 minute commute each way. It was pretty horrific, actually. And you just get to work and you'd be half dead. The idea of sitting down for 4 hours and then having lunch and another 4 hours on some very complex technical problem with a team of people, you just didn't have the headspace for it, I found. And when I came back, I was a bit nervous that I wouldn't be able to do it anymore. But in fact, I was able to do it again almost immediately. So, this is a tough example, right? But, Oak Ridge, when that was set up to work on the original nuclear bombs, they got all the world's physicists and they put them in a place that was idyllic. It was set aside from the problems of the rest of the world. All their families were taken care of. The kids got a nice school to go to, and they didn't have much to worry about besides working and spending time with their family. They were able to accomplish these amazing, terrifying, but amazing things as a result of that. The US seems to get this. A lot of big companies have research centers in small towns in the US. This is a pretty common thing, actually. But for some reason, we just decide everything should be in, Melbourne or Sydney in Australia. They're cities that are becoming a little bit unwieldy. And I find that one of the things that seems to get lost is the ability to focus and concentrate and work on very technical problems. So I quite like being in Darwin. It's kind of very Oak Ridgey. It's small, it's easy to get around. It's a very idyllic place to live. And, we've had people move here to become part of the research team and love it. It's a matter of valuing the environment you're in and kind of engineering it to get the outcome that you want. For me, at least, I can get a lot more purchase on the problems that I've got to bite on by being here and kind of being less intruded upon by the environment.
That's a good answer, and it's been a good conversation as it was last time. Thanks very much for joining us, Steve. It was a pleasure to speak.
Yeah, no worries. Yeah, great to catch up with you.